What if our universe isn't alone? What if it's just one small ripple in a cosmic ocean of endless realities, each one with its own rules, its own physics, its own version of everything, including you? If that sounds like science fiction, you're not wrong. But increasingly, it's also serious science. Today we're diving headfirst into one of the most fascinating and controversial ideas in theoretical physics. Is there another universe beyond our own? Or could there be infinite others? Let's start by defining what we mean by multiverse. This isn't just one idea, it's a term that encompasses several models. Some are based in cosmology, some in quantum theory, some in pure mathematical logic, but they all suggest the same unsettling possibility. What we call the universe may only be a fragment of a much larger structure. So let's explore the four major multiverse theories that scientists are seriously considering. The first is the bubble universe, which comes from the theory of cosmic inflation. Just after the Big Bang, the universe didn't just expand, it inflated rapidly, almost faster than light. But here's the thing, according to some versions of inflation theory, this expansion didn't stop everywhere. In most regions, it kept going eternally. But in a few pockets, like ours, it stopped, cooled, and became what we now call a universe. Those other pockets, they formed other universes. Each one may have completely different laws of physics, one with stronger gravity, one with no atoms, one where the speed of light is slower. Most of these wouldn't support life, but with enough of them, it's not surprising that at least one does. Next up, the Brane Multiverse, from string theory and its higher dimensional cousin, M theory. String theory proposes that the fundamental building blocks of the universe aren't particles, but tiny, vibrating strings. When this theory is extended into higher dimensions, it suggests our entire universe could be a three-dimensional brane, short for membrane, floating inside a higher dimensional space. And just as pages can sit side by side in a book, other branes might exist right next to ours. They could be separated by a microscopic distance in a direction we can't perceive, like a flatland creature unaware of up or down. These branes may have their own universes, complete with matter, energy, and even their own versions of time and space. Some theories even suggest our universe was created when two branes collided, releasing enough energy to create an entire cosmos. It's bold, it's speculative, and it might explain things we can't yet account for. Then there's the Quantum Multiverse, which might be the weirdest one of all. In quantum mechanics, particles don't exist in just one place or state. They exist in a cloud of possibilities until they're observed. At that moment, they seem to choose one outcome. But according to the many worlds interpretation of quantum mechanics, all those outcomes actually happen. They just branch into separate realities. Every decision, every coin flip, every quantum event splits the universe into versions where each possibility plays out. In one universe, you clicked this video. In another, you didn't. In another universe, the roles are reversed. You're the physicist, and I'm the one taking notes. It's strange. But some physicists think this is the cleanest explanation of quantum mechanics, because it avoids the messy question of how and why wave functions collapse. And finally, the most philosophical of them all, the simulated universe hypothesis. This idea suggests that our universe might be a simulation, a kind of artificial environment created by an advanced intelligence, maybe for research, maybe for entertainment, maybe for reasons we can't imagine. If they can simulate one universe, they can simulate many, and if those simulated beings build their own simulations, we end up with layers of reality, a multiverse of simulations stacked on top of each other. Some researchers argue that the math behind our universe is suspiciously clean, that quantum uncertainty looks more like pixelation than randomness, and that if civilizations survive long enough, creating simulated realities might be inevitable.